250 million years ago, the Earth that we live on today was devastated by the greatest mass extinction event in its entire existence, the Permian Extinction. This largely destructive occurrence wiped out 95% of all life at the time due to the merging of the supercontinent Pangaea, which caused huge temperature variations and volcanic eruptions. Throughout this documentary, we will explore the past, back to the Permian period, talk about the changes in the Earth at the time, and its comparison of what is happening in the world around us today. The Permian extinction can open our eyes on the catastrophic events that we as a whole don't consider, yet is occurring all around us at this very moment in time. A great example of similar occurrences between both now and the Permian is a large increase in global temperature. During the time of the Permian, the Earth's global temperature increased by a catastrophic 6 degrees Celsius. This temperature increase is currently accelerating the rate that many of the species today are heading to extinction. Up to 1 in 6 species, 16% of all species, will be threatened of extinction by the end of the century. The planet's temperature problem was majorly provoked by the large increase in carbon dioxide, methane, and other greenhouse gases that are being spilled out into the atmosphere by many corporations and factories worldwide. Earth today produces one of the most amounts of carbon dioxide it has ever had to date. Out of 3 parts per million increase per year, we are growing very quickly to an irreversible problem. During the Permian, a similar rate of greenhouse gases increase rose the global temperatures by 6 degrees. The greenhouse gases during the time of the Permian extinction was most likely due to the large amount of volcanic activity at the time, which would have let out tons of greenhouse gases worldwide many times over. Underwater volcanic activity formed what is called a methane burp, that is a large buildup of methane gas that will rise to the ocean's surface from submerged volcanoes and will release dangerous amounts of methane gas into the atmosphere. These methane burps were potentially one of the major reasons for the initial temperature increase, and altogether one of the major reasons for the Permian extinction event itself. During this extinction period, the acidification and anoxia of the Earth's oceans was a catastrophic thing for marine life, particularly crustaceans and other shelled organisms. The acidification of our water was caused by an increase in carbonate ions entering the water and disturbing the world's oceans of 50-to-1 ratio of water to carbonate. This resulted in an increase in hydrogen ions and decreased the pH level of the ocean, increasing the acidification of the water at the time. Ocean anoxia is the loss of oxygen in the water. This results in marine life not being able to get enough oxygen and beginning to suffocate. The oxygen in our oceans is also used to block out the amount of hydrogen sulfate being released into the atmosphere from underwater volcanic activity below. Yet if the oxygen level continues to decrease, there will be more hydrogen sulfate greenhouse gases allowed to be released into the atmosphere, and in turn will continue to cause the greenhouse gas effect on the Earth's atmosphere and destroy the ozone layer even further. The varied temperatures and conditions throughout Pangaea created cold southern temperatures and intensely hot northern temperatures. This made it easy for reptiles to survive due to their cold-blooded nature and desert-type habitat. The daily temperature of this time period ranged from below 0 to over 38 degrees Celsius. Both the Edaphosaurus and the Pelycosaurus were reptiles alive at the time that survived throughout the extinction event. These reptiles were suspected to have turned warm-blooded after a while in order to conserve their heat energy. We are believed to have evolved from these very species, yet most of the other species alive at the time were driven to extinction due to the severely harsh conditions at the time. Soon after the Permian, there was a period of time known as the Great Dying. This was as a great volcanic eruption in Serbia drove 90% of the population into extinction from the lava, greenhouse gases, or temperature increase. This great dying was discovered by an overly large amount of fossils in the rock from that time period. The time after the extinction period is known to contain little life by records of the dead zone, which is a large gap in the rock with limited amounts of fossils to suggest what life was like at the time. It is estimated that with the amount of lava in our oceans, the amount of carbon dioxide being released into the atmosphere is now similar to the amount released in the extinction period. This amount is calculated to possibly increase the global temperature by a further 5 degrees Celsius, which will certainly lead to many extinctions. Or a 10-degree change is predicted to produce another mass extinction of 95% of all marine and land species alive today. In the late Permian extinction, the carbon dioxide level was 3,314 parts per million. It is now 408 parts per million. There are small signs that the Earth is repeating its greatest extinction event, yet these signs are nowhere near as extreme as they were then. We should still see the signs and change the way that we pollute. In conclusion, these events show us that we are speeding up the time between the last global extinction event and the next one. We are forcing our own extinction event onto ourselves by producing large amounts of carbon dioxide, methane, and other greenhouse gases. It is true that these signs will occur naturally, as it has many times over the Earth's history. Yet we don't know how long it will take for us to reach the next stage. It would be best for humanity if we take all these signs seriously and change the way that we do things, with the Earth's benefit first.